Welcome back to session 34. We will continue with our reduced form models of credit risk. And now we are going to talk about Markov chains. In the first part of this exposition of session 34, we place a lot of emphasis in the single stage credit deterioration models. Essentially, a company would move from a state of being current into a state of being in default. But the fact of the matter is that it usually is a multi-stage process. We can go from high-quality credit ratings to mid of the table credit ratings to junk to default. And the process takes time, usually, and there is a degradation of the quality or an upgrading of the quality depending on the issuer. So it is possible to have matrices that describe the probability of transiting from a given state in terms of credit worthiness to a different state. Here we have one that takes 8 steps in the ladder of credit worthiness from S&P. So we will start from AAA and we will end in default. From AAA to default, there are different probabilities of moving from this stage to this, from this to this, and so on and so forth. We can also see it in reverse. This probability table is a very useful one and will allow us to get a sense of how the spreads between different credit qualities are established. So we start with a simplified version of a credit matrix. We're taking it literally from Hull's book on options, futures, and other derivatives in the 5th edition. And this is actually Markovian matrix. So we will start with some useful interface. What we have here is the risk-free rate, and here is a number of steps. As we know from Markov's theorem, the probability of going from one state to another state in k periods is described by the Markovian matrix elevated to the kth power. So we will do that work with the help of Maple, and we will see what the probability is from being AAA quality to go to default to being in default and staying in default in k periods. The transition matrix after k periods can be described by this three-dimensional matrix plot. The height of each one of the bars corresponds precisely to the probability. So just let's take a look at how the transition matrix changes as the number of periods increases. So we go to 10, to 20, to 11, to 20, and look at this. This is very, very nice. How we go from high probabilities of being, let's say, current to higher probabilities of falling in default. So as we move further and further away in time, eventually many of the companies or the issuers who were different from investment grade or from extremely high quality will eventually fall in default with a significant probability. So the first 3 notches, even after almost 50 periods, still have a very relatively low probability of default. But as we move into lower credit quality, then the probability of default increases substantially. What this means in terms of the value of the loan is how the value of the loan goes down as the number of periods change. Look at this. I'm going to go to shorter maturities, and in that case, the probability of default is very, very small, even in bonds rated in the fourth and fifth steps. Then, as we move further into the future, then this gets really steep. As one should expect, there is a counterparty between the value of the loan and the spread. This is the spread in bips between the risk-free rate and the rate that we should expect to see for each one of these loans. Notice that in this case, our vector misses one row, which is the row corresponding to default, to avoid an undetermined result coming from a division by 0. So what is interesting of this exercise is that what we see is that underlying credit spreads and term structures for those credit spreads, as we see here, and as we see here, there is a Markovian matrix, a transition matrix for the Markovian process. This is generally known in the literature as the hidden Markovian matrix for any term structure. We will continue talking about these and other issues in the next few sessions, but for now we are gonna take a break here and we'll resume in a few minutes. Thank you very much.